and does it record? No. Yeah, okay. So I made a small presentation. I think you guys can see that. So let me start the slideshow. So basically, let's go to the beginning. So yeah, hack session, face anonymization. All right, we are here all together. Thank you so much for coming. And yeah, so I put a lot of goals on this slide, which I think like today we could use the session a bit more to talk about, you know, like what is the goal, what is the idea behind all of this, and so on. So like yeah, so the major idea is like to create an algorithm to remove faces and personal information. So like from images. So like at first we will start. I think we will start with faces, but in the end, like detecting faces is kind of a way of detecting objects in a broader sense, you know. So like maybe then the solution that we develop here can also be applied to other classes, not just to faces. And then the idea is that we want to apply this algorithm to all images uploaded to our image data set. So like everything. So like I mean, I'm a big believer that there will be millions of images in the future. So there is then also an algorithm which will have users in the marketplace, in Ocean Marketplace. And also like that's also then the goal to list it on Ocean Marketplace. How exactly we want to do this to not, you know, to have a pool, but then to not drive the price up too much. I think that's something we can discuss later. So I think also on Algovera, there's in the tokenomics part, Jakub and you guys are talking about this already, how to do that. Then the next thing is like, that basically we want to have original images that will be stored in a data set, you know, like our DataUnion data set. And then it's like this, that we have a data portal. So this is already live, squid.dataunion.app. And there we want to show preview images, you know, like, so like a small image, but basically that the user can select which images they want to work on. We also then, maybe I can just show you this. I don't know if you have seen this already. But like this is a platform, it's been online for quite some time now. But here, so you log in with your MetaMask, so I can then also now see like this, everything that I uploaded personally. Like these are the images. So like here you can see me and my wife, but I mean here I can now see our faces. So like that's something that we actually do not want to have in the future. Or here, Ilya, you know, like this face should not be visible. This is it's not the original image, but it's like, this is like a compressed, scaled down. In the original image, it's like a very high resolution. And then there's a watermark also here inside of this image. So somebody who wants to steal the data cannot really steal it from here. But we basically want to make sure that we kind of run a filter over this. And that's also the idea of this algorithm. So like here, basically, you can also look for tags. So I think humans, I kind of, okay, you can search for humans. So yeah, here you see, I mean, basically here we want to filter out these faces. So like basically then we can let people search for everything, you know, but inside these images it's not really shown, you know. So like that's an important part, because otherwise we are kind of infringing on the people's personal rights. And so like that's why I have the intention now to start working on this algorithm, and why it will be then applied to basically every image that is uploaded, because we want to make sure every image goes through this filter. And if there's an annotation, then basically, so the detection will then be an annotation on top of the image, and that's then shown in this platform. So yeah, and if you work via computer data on the data, it will not be the case that you can see the original image, but just for anything outside of that, we want to have this application. And of course, maybe somebody wants to use it for anonymizing data sets as well. So I think there's also a use case outside of DataUnion, but we have a concrete use case, and we then basically will buy it all the time. So there's basically something to make a turnover anyways, you know, and then we will basically pay for that. And so yeah, then the goal is to put this algorithm also in a continuous evolvement process, so that new uploaded data, which has then faces in it and they're annotated, that this will be basically retrained over and over again. And so we also have a mobile app to fool the algorithm on purpose, and then also use these images to enhance it. And then the last point as a goal is like to distribute the value created by the algorithm to all the involved contributors, data scientists, data contributors, algorithm evolvers, and facilitators. So yeah, that's basically us here. So like maybe we can, I can stop a little bit here, and we can think about this, you know, how we can do this kind of thing. So like there are several options. So yeah, here, so like then the next slide is how do we get there. So like we should find out which we should start with open data sets. From my point of view, I found some of them which are pretty good. So like there's also from Google a larger one, and we have this balanced faces in the wild. Then which algorithm should we use? How we will get some GPUs to get going? We have some. I can allocate some. But yeah, maybe we also have to think about how to do this in a more like if we want to start a training, that we let that train, then later we can evaluate it and stuff like this. And so how will we share the results and the long-term value, and how will we work on this? So I think GitHub repository and Google Docs is a good start, but my personal view is like start pragmatic and evolve from there. Yeah. Okay, so I've been talking too long. You guys have any inputs? Should we discuss this a little bit? I'm not sure how I'm deviating now a lot from the normal process of how hack sessions are run, Richard. But yeah, that's just my idea. You know, like you're eating, no problem. That's good. Yeah. So what do you guys think about this?
I mean, algorithm-wise, it seems like a very generic kind of a use case, something which can find a lot of adoption from the industry, I would imagine. I'm not from this field, but from the outside, it feels like something very, very valuable. And yeah, building it should be fun, I guess, with the data that's available. And I wanted to understand from Robin whether is there going to be any kind of a domain adaptation that will be needed based on, I mean, do we expect this to be a generic face anonymization use case, or will it be embedded in some specific context so that some off-the-shelf model, we do not expect it to work right away, so we have to train it on some use case specific data set, anything like that, or we can go ahead with off-the-shelf model, train it, and just keep on evolving it?
Yeah, from my point of view, we want to make this now as general as possible. And I mean, it's also, of course, a long-term goal. But if we have something, you know, that works, or several things that are okay, then we can basically evolve this over time by using it in the DataUnion image data set, you know, by applying it, and then there will be a result. So maybe yeah. So like, yeah, I think it should be very general. So like, I can also show what we have in our mobile app. I can also show a short preview of this later. But I think if anybody else wants to add something at this point, yeah.
Yes, just in terms of the anonymization, is that something like the model will identify there's a face and it will blur the face, or will it replace it by like a synthetic face, like from StyleGAN? I'm just trying to understand, like, because I guess like different types of anonymization will require different models.
Yeah. So, but in the end, if you want to replace it with something else, you can also first find it. So like, I want to take it this step by step. Of course, like replacing things with synthetic data is awesome. You know, then you could also say on even the model training later, which will happen on the data, will not see real faces, which I am not quite sure is the perfect way to do. I mean, there's a startup in Germany called Brighter AI. They are putting this as their flagship product, you know, replacing faces with artificial faces, license plate with artificial ones. But I'm not quite sure, like, whether the results on then real data will be the same. Also something we can explore. From my point of view, starting as simple as possible is the best approach. You know, like saying, okay, we want to detect something. Of course, I would not like to sell a face detection algorithm on Ocean Marketplace. That's why I'm always talking about face anonymization and not face detection. You know, like basically the last part is then just like, where you find it, you blur it, or you replace it, or you cut it out. I mean, with the blurring, they also have shown now in papers that they can reconstruct the face, you know, like just like by using a synthetic filter like on top to make it to reconstruct the face outside of a blurred image, if you don't use a proper blurring function. So I mean, you could just put in some other part on this. In the end, like the real application that we're working for now is like this platform. You know, like I'm quite sure I will, for every image that will upload it, I'm willing with DataUnion to pay that and to apply this. Of course, then also DataUnion will own this annotation. Like the anonymization part. If somebody later then wants to buy that, then it's already there. So like every annotation that is basically made can also then be bought by somebody else to use it. Like if somebody wants to then and do something more with face detection, then this algorithm has already done the annotation. So like then basically all of us here, as we build this in the DataUnion mind space or value distribution, we will get a share of that. So that's the idea, to have then this annotation of faces inside the data set. And for this, if we show it to users, then it will be applied, and or we will apply it to we make a thumbnail, and that will be stored then. And then one time when we detect it, it will be applied, and then it will be stored and it will be shown to anybody who wants to buy it in the future inside our platform. So yeah, but in the algorithm, this last part will be included. So I don't think we want to be something like Clearview AI and like offer people to detect faces. Like maybe China becomes a customer and takes our model. I don't necessarily. If we put the blurring and the anonymization inside of the algorithm, inside the Docker container that you can then access, then we are kind of fine from my point of view. It's not useful for malicious purposes.
So sorry, no, go ahead, Richard.
I was just going to say, yeah, I've actually worked with a face anonymization algorithm before, and it's basically just face detection with like, a pixelation, a very simple pixelation function. I can show you what it looks like actually, just as a shameless plug of my paper that I'm working on at the moment as well.
It's a paper for your work, or
can you see this?
Yeah.
Yeah. So yeah, we were basically publishing a paper and we didn't want the faces of the athletes to be seen. So I just ran a face detector on all of these videos. So I actually made like a video result of this entire tackle as well. So there's a video that you can watch of this as well. But so I ran the face detector on each frame. Where's it gone? I ran the face detector on each frame, and then there's like a very simple pixelization function. So you can like choose the number of squares that you want to, make different levels of transparency. So I think this is like a 3x3. So it looks kind of like, if you looked at it quickly, you wouldn't even notice the face isn't there in the images. So we could use something like this that I've worked on before.
Yeah. So yeah, I mean, Jakob, you wanted to add something more?
No, I was just going to ask, like if it's basically like detecting where the face, like the model would be detecting whether there's a face and where the face is, and also I guess I don't know how much complexity that adds to the model, but if the images are different sizes, I guess it's also about not just detecting like one point center of the face, but also the size of the face.
Yeah.
If the model you showed us, Richard, can also do that?
We tried a few different face detectors just like out of the box from GitHub, and the first few didn't work because that's quite a hard use case where the faces are quite small and like they haven't been trained on data of like rugby tackles or anything like that. And so yeah, we just tried a few different ones until one of them worked. So I guess some of them are more robust than others, but that one that I use seems pretty robust. So yeah, we'll just have to try different algorithms and see which ones work, I guess.
Yeah, maybe we can start with this one. So like that's not, I mean, pre-trained algorithms. Okay, I didn't put that on the card, but yeah, we can also try those. In the end, yeah, I would probably use these data sets that we have from Google directly, just distribute them in training and validation, to then also see that we have a validation data set which is, like which has different kind of facial features, colors, age groups, and this kind of stuff, so that we align on this, and then we can always validate our approaches against something like this, and then see how good our performance is. And yeah, so I think that this would be also a good idea to start with. But in the end, like this is something, Jakob, that is really one of the points. The images that people upload are going to have different sizes, and this is like in computer vision, it's a problem. Like it's not necessarily that your image can really work on that. But then the idea would also be like, okay, let's use different sizes of images to either use different sizes of images to basically train, or take an approach and take the image and cut it into pieces that are of the size that really works, and then show these different slices of the image to the detection model. I mean, like if I cut now here my screen in 2 halves, and I can also show this. The problem is only like what is in the middle. So like you have to cut in 3 slices in this case. You have, well, still, yeah. I mean, it's going to be a little bit of an issue, but I think you can just cut the image and show it multiple images. Of course, then it's more cost intensive because you have to run the algorithm multiple times. But yeah, that's something that we have to live with. Yeah.
I think it would be a good place to start with pre-trained models, just to get a benchmark for how well they work. And then for sure, we want to try and improve on the performance of those models with this more diverse data set that we can crowdsource much quicker. And so, yeah, it might be interesting. Since we have it already, we can just run the exact same pipeline that I had, the face detector and the pixelization, and then start to go through it manually and see maybe which cases it's failing on, which ones it's working on. Yeah, I mean, the other thing I'm really excited about for this project is that we're trying out this crowdsourcing of data with training of models for the first time. It's like a proof of concept for that. And so we were talking about this yesterday, Jakob, in a different meeting, but this has advantages over the traditional way that machine learning is done, because what usually happens is you work in a company, you capture a data set inside the company, maybe in your local area or across the branches in a few different countries. That's an in-house data set. You train these algorithms until you reach a certain level of performance, and then you want to deploy it in the real world. And then what you always see when you deploy it is this drop in performance, because the distribution of real world data is different to the distribution of the data that you trained it on in-house, for example, right? But now that we have this tool for crowdsourcing, we can actually crowdsource it from the real world using the incentive mechanisms of Web3. And so hopefully there's less of this performance drop when you move from your in-house data set to the real world, because you can actually just train on the real world in the first place, right? And that has lots of advantages in terms of, the speed that you can crowdsource data, the volume, like we were saying yesterday, Jakob, you can get more data. And also the diversity of data is better, which should be better for fairness and things like that, because, we can crowdsource data from lots of different, countries, ethnicities, and all this sort of stuff. And so the algorithm that we create from it should be less biased. And so, yeah, I'm just really excited. I don't know, Robin, is there some way that we could incorporate that into the hacking sessions as well? If we found that there was some case that didn't work well, could we put up a bounty or something like that for?
Yeah. So, I mean, we of course, I started the hacking session too early because this is not completely finished yet. But I mean, we have now a lot of engineers working on this. So I think as we now work with this data sets that we already have, set up something, come to the conclusion, okay, we now know, okay, this works well. Then I think from the timeline perspective, we should also be able to have then our new version of the mobile app, which has this specific sourcing mechanism included, So yeah, we have now 15 engineers working on this kind of stuff. So yeah, they're making some progress, but yeah, it's software development. So I'm fortunately in the situation I don't have to give exact deadlines yet, So we are VC funded. I did not promise them anything, when something would be done. So it's okay. I don't have to give monthly reports in the Ocean DAO, that everything is done to get new money. That's a fortunate effect. But yeah, so of course this is one of the goals, that we put this into the loop. I can call this human in the loop, so even incentivizing people to actively trick it, if I do like this, and other people say, hey, there's still a face here, but the algorithm says, no, I don't see the face. Well, I mean, this is a great example to add to our data pipeline, and now say, okay, well, these are also faces, and the algorithm should also detect that, and then blur out this part of the face, and with incentivizing people to challenge the algorithm, I think at some point we can make a pipeline and a system that the algorithm will be extraordinarily good, so maybe even detecting things that are not detected by other algorithms at all. And then in the long term, we can maybe have an algorithm that is, yeah, probably better than everything else out there, because people, we can ask everybody on the planet, if you add your face to that algorithm, we know that you will be filtered out in the future, everywhere where somebody wants to use something where faces are detected, yours can be detected on one side, but also then removed, so that's something where we then have because everybody on the planet has the incentive to become part of it, you know. So that's why I think it might be also a good use case, you know. So like, yeah, but we have to be very careful on the other hand, because like a lot of jurisdictions see all of this as a problem, you know, that you can detect everybody. But as long as we don't capture who they are and can identify them, I think we're kind of okay. I mean, we have the intention to anonymize data and not to do the other thing, like to identify people. So yeah.
How do you train an anonymization algorithm without having a face detector in the first place? It's like chicken and egg, right? You know,
Possible.
You can't detect faces to anonymize them if you don't like label data to detect faces in the first place.
Yeah, I mean, that's why it's good that our company is DataUnion is we can host the data and stuff like this. We are in Singapore, so I don't have GDPR issues, and all, like that's not such a problem. We can also store the data then yeah, somewhere where it's not necessarily, you know, like an issue. So I think, yeah, we will be fine from this point of view.
I have an idea for an interesting experiment that I was just thinking about the other day, and I don't know what you think about what would happen, but let's say we want to create an anonymization algorithm, for example, right? And we choose a model and we randomize the weights initially, right? And then we haven't trained it on anything, and we ask a user to, like, you know, check if it works, and we know it's not going to work. So it doesn't work. For every image that it doesn't work on, you add that image to the data set. And so, like, for the first image you add, for sure it's not going to work, right? So then you add that image to the data set, then you retrain the model on just that data set of 1 images. And then, you know, the next time that person checks whether it works, it should work for them, right? Or maybe it doesn't, and then they just, because it's a different orientation or something like that, and maybe you add, you know, this one to the data set. What if you did that? What if you did that one by one and just iterated that every time an algorithm was run on an image and it didn't work, you added that image to the data set? What would it converge to a point where it generalizes, you know?
Of course it
should.
Like, from my way of thinking, yes, but I would do like batches, 100 images at a time, you know, like not one, because, like, you know, it's kind of expensive. But yeah, I this is exactly the process that I'm foreseeing, like, and why one of the things why we want to build this in the mobile app, you know, like this challenge mode. Like, basically you apply the image to yourself and you try it out, and then if it's not successful, you can then upload it, you know, like. But as so like I'm always seeing like applications of algorithms to be cost intensive, you know, like, because it always costs something. So like at the moment we have sponsorship by AWS for ourselves. So like it's all right in this direction, but still it's not an infinite amount of sponsorship. You know, like if I want to have like 10 GPUs at the same time, our money will be gone in 2 or 3 months. You know, so like these are the issues, you know, that we are thinking about. And yeah, we now have partnership with like a decentralized compute platform. So maybe we can also get something from them, you know, like some resources in the longer term. But yeah, for now, I would say we start something with these algorithms. We start by distributing the data set into different parts, you know, one for validation, one for training, and then we see how it goes from there. We can try the process, you know, like artificially. You can take an existing data set and then add images one by one. But I mean, it's like probably it will work for my understanding of machine learning. But in the long run, it's also going to burn a lot of resources, you know. So that's probably the way it is. So I would rather take a model that already exists and then like collect a batch, then check that, and then, you know, like retrain on batches and stuff like this. So yeah. But in principle, that this is exactly what I'm also excited about, crowdsourcing and doing these things together. Yeah.
And these experiments haven't been possible before. Like, I don't think there's any tools that you can do this. Like, we had Amazon Mechanical Turk, but I think that's where you give them a data set and then the humans label it. I don't think there's ever been a way to like crowdsource data from anywhere in the world and like pay people, incentivize people to do that. Is there? Okay.
So let me show you. I mean, I have to jump to the next meeting very quickly soon, but let me just show you this, why I'm also excited a little bit about doing this in the loop. So like there's this one thing here, it's called Dinner Bench. So it's a product. Maybe, I don't know if you, so like here, Dinner Bench, rethinking AI benchmarking. So like here, there's natural language inference, sentiment analysis, hate speech, question answering. So now this is more about NLP, but you can also see here like that there are rounds and how you can contribute something, you know, Like people can actually, for all of this BERT, if you know NLP, you know the BERT model and this kind of stuff. So like you can actively really here contribute stuff. So I also tried this out. You can create an example. So basically where you are going to enter a helpful or non-helpful example and to fool the model, and then you can validate things from other people. So I mean, I already have an account here. But yeah, so I mean, in the end, yeah. So this is something that somebody is actively developing or like using for these models. And I mean, what's not shown here is, I mean, maybe can you guess which company does that? So it exists already. So can you guess which company owns this platform?
Facebook.
Exactly, you're right. This is a Facebook.
As a guess, yeah.
And they give nothing back. You have to understand. You're not in the platform, you're the data slave, and now on Dinner Bench you're even more the data slave. You're even doing the work for them and get nothing. So like, yeah, so I think even if they have the idea and the people are using this for free, I think we have something on our hands here which we can develop also then. And this, I think this anonymization algorithm is going to be one of the good examples, you know, to show whether this works or not, because it's a very convenient thing, you know, like everybody has a face. So everybody can get involved, and like it's not something that somebody else has to know the same one. So like every data point is valuable, you know. So yeah. Okay, yeah. Right. So from my point of view, I would invite for another hack session if you guys are interested. And Mohammed, you want to add something?
Yeah, I'm actually in between commute, so I couldn't speak. But Hugging Face Space has one very good model on these that we can take a look at. And also, there's also actually a face mask generator that's there also. So that would be also very helpful. So
yeah, I would
probably share them.
Yeah, let's have a channel in Algovera. So I would say in the Discord, let's share what we find in there. Let's collect a little bit, and then we make another session maybe next week. It's the same time. Is this okay for you guys? Then we just make another call and we check in, and then we take it from there. Just like, you know, everybody does how much they want, and maybe at some point we can make a coordinate around like who's providing how much value to make a reputation system first, maybe not directly about money, but like to keep track of how much people were involved, and then just we basically track this for each other. You know, we say, hey, you did this much, you did that much, and then we can connect. If we don't start collecting this information, then in the end it will be difficult to say, okay, this person gets this much, this person gets that much. And I think we can try it out. You know, we will see. I would like to try this, Richard. Is this okay?
Yeah, for sure. Yeah.
All right. Okay, good. Yeah, then let's talk again next week and in the channels. Have a great weekend, everyone.
Perfect. Can you send me the recording, Robin, by the way?
Yeah, I will do this. We can offer the recording on both YouTube channels maybe now.
Yeah, perfect. Great. Okay.
Bye-bye.
All right.